I think my passion for science may be something that I had in the blood early on, because I think I was born very curious. I've always been very curious. I believe I've always been very creative. I love to play and doing stuff, and always very curious about understanding how does it work. When I was a kid, I used to break apart stuff just to understand how it works. Of course, I was not able to bring it back. It was not something very nice sometimes for my mother. But I think I'm born scientist. Though I'm very curious, I'm very math gifted. So I went kind of naturally into physics, because that's something I feel at ease. And that's something that was responding to my kind of, let's say, my internal voice that maybe that's something I should be doing. I can never stop asking to myself, oh, why is that? How does it work? And why did we do that and not that? And I'm also curious about, it's not about physics only, it can be about psychological pattern, about the way the society works, the way the financial system works. I think I'm very eclectic, and it's a kind of a soft madness in a way that I always want to answer. And obviously I very rarely got any answer, but I really want to answer. And that's, I guess, this kind of emotional drive, or even maybe a bit obsessive drive, that brought me to science. I cannot identify a specific person that had a specific influence, but I have had a lot of people that may have played some role. Well, first, I have a very supportive family, so I think this is essential. I don't think if you are under stress and under threat in your family, it's not possible to do that. You have to get a free mind. So I can really do what I want, which is what I wanted, which actually was certainly a good starting point. I've had a very interesting teacher sometimes, because it was the 70s, it was new teaching in the 70s, a new Piaget theory, so they were kind of funny teachers, so maybe it helped to develop some creativity into me. I cannot really say I have had amazing physics teacher, but I remember very well my mathematics teachers, and I like it very much. I mean, they really brought me to mathematics. And then I went to physics. I realized that there were a lot of cool topics that I didn't know. I read a lot of books, some of the kind of almost public-oriented, and writers like Carl Sagan, for example, was one of them. I got very, very thrilled by this. And all this together was a nice music to my ear, and they all together brought me to become a physicist, and then working on astrophysics. So that's the interesting aspect of working with Michel. I think I picked Michel because I think we're very similar in the way we operate. We're very instinctive. We are kind of emotional, and maybe we can say Michel is not very academic in that style. So it's all by touch. It's a bit like do paintings. So I cannot say something specific, but the whole touch paintings that you get by working with Michel, by getting bits here, I think was amazingly useful. And still today, I mean, I just love being with Michel. I love listening his perspective of things. He has a kind of sometimes awkward perspective, and I like it. I think we all need what I call a mentor and inspiration. So Michel was certainly a mentor to me. I learned a lot. And he helped me at least to develop some skill, not directly, just by being with him and maybe having some kind of discussion about something, and then they will help me to think a different way and to develop other skill. So I must say I've been very fortunate to be working with Michel, and I hope the same for him, because I think Discovery was an amazing teamwork. Well, it's always difficult to give advice to students, but usually the way I interact with my students is I try to do what's called light touch supervisions, which it means you have always to be there when they really feel under stress, because we're here for really do the net here. But it's also up to them to find the way. So you can show the way, we can suggest the way, but very, very quickly I try to promote this kind of spirit, let's say artistic spirit. I mean, that they try their own way to go through what they're doing, and in a bit of provocative way, if I try to translate that, is don't listen to your supervisor in a way. and do it as you feel. Of course, you should not apply that strictly speaking, but I think it's part of this kind of light touch, and that helps to develop confidence in yourself, that you can do something without being told that you do it. But it also helps you to listen and to try to grab in the couple of advice, which is the one that fits you the most. And I think, to me, that's a perfect interaction you should have between a student and a supervisor. And there's something for sure that all students have to understand, and they should really develop their own perspective on things, and they should not be afraid to build confidence. And quite often I'm facing with a lack of confidence, and the confidence is a matter of self-respect and also self-build-up. And the best way to build up confidence is just do the things. So do the thing, don't listen too much to your supervisor, and listen to your guts. Oh, the reason why I love working with students is every day they teach me something. Because, well, first, their brain is much more fresh than mine. They come with a very fresh perspective, which some of the time bring new ideas. I got too spoiled because I know too much, which is bad if you want to be creative at some point. But they come with so much energy that is so wonderful. So I just love working with students and PhD students and working team. I think that makes my day really happy. Well, I was a PhD student, that's true. But in all discovery, there's a matter of luck. It's a bit of a gamble. So we have been lucky. We could have been scooped. Other people could have found this before us. We have been lucky. We work right. I think the fact I was a PhD student certainly plays some role, because I came up with maybe a fresh perspective, and in another way maybe that Michel would have done it. So this kind of teamwork that we had with someone way more experienced and somebody way more energetic and maybe way more naive and creative in a way was a terrific team. But there's no rule. I mean, just do what you think. I mean, look, when I was doing that, I never thought about Nobel Prize at all. I just thought I was cool what I was doing, because I just loved it. I was doing something new. I was pushing the boundary of the knowledge, and I was great because we were doing this work. We were exciting about what we were talking and discovering and announcing to the world. But at no point I thought I would build a career and have a Nobel Prize. So I think it doesn't really matter if you're a PhD or if you're a junior scientist. Just do it because you believe you have to do it, and just have fun when you're doing it. Oh, my day was really awful. I had problem with my bike, and I had to fix my bike, and I was late, and the day was starting really on the wrong foot. Then it turned completely in another direction after this phone call. Not from the Nobel Committee. Actually, they failed to reach me, but by the PR office of Cambridge, because I was at Cambridge, that called me and told me after the announcement, because I was not at all looking at that. I was in the middle of a meeting. Nobel Prize was the last of my worries, and they told me, "Are you aware that you got a Nobel Prize?" I first thought it was a joke. And then I realized it was the 8th of October. And I said, "Are you sure?" And I was so convincing in the way I asked them, "Are you sure?" For a moment, they say, "Oh, just wait a minute, we're checking." And they came back, "Oh, yeah, that's you. We see your face." Okay, I say, "Oh, my God." Then I lost track of the day. They asked me what I would do with the prize, and I was so annoyed with this bike. I said, "I'm going to buy a new bike." That definitely is in the plan. So I'm looking for buying a new bike. Oh, this is a difficult question. See if there is any other past Nobel laureates. When you look at the list, I mean, there is so many great figures and so many great physicists. I cannot identify some specific one, but there are certainly a lot of great names that when I was a student in the physics, I learned the history and I learned what they did. So certainly the Nobel laureates is certainly a good pool to pick a great lot of people, but I don't have a clearly a specific name to tell you right now. Well, I'm still learning what does it mean right now to become a Nobel laureate. It seems so extravagant right now what is going around this. I don't really know. I just saw the first effect. Everybody seems to be interested by me, and they all want my signature, and that's what I see right now. I'm waiting a little bit all this to cool down because I don't feel I'm very different. I'm still the same person. I don't think my science will be very different. But certainly I do feel a sense of responsibility with this prize. And it will take a bit of time for me to digest absolutely everything, what it means, and what I can do with all this, with this prize. Oh, I don't have a lot of free time. That's my problem. So the few time I have left is I try to dedicate to my family and to my wife. And we love just taking care of the house, doing gardenings, and when we can, traveling a little bit. And I save a bit of time to go on the mountains because I love to ski, so to do skiing. And we'll be trying to save a bit more time to just go to a nice place when we can just go to the beach, just enjoy a bit more relaxing time. That's really the optimizing the few time I have. Most of my time, it's absolutely obsessive about science. It's just a disaster. It's just so obsessed. Well, I think people that have an interest for questions and like the rational reasoning, and even if you're gifted for logical thinking and mathematics, which is not everybody, but if you are gifted, you have to do science because that's where you will develop all this gift the best you can. And science is essential to the society. It's everywhere. I mean, all the science and our society we're living is the outcome of science. Your cell phone is full of science. So I think we need scientists, and what we need the most is not only scientists, we need scientists in the government making policies. Because when you look in the parliament, when you look in the governments, there is an absolute lack of scientists compared to the weight of science in our own society. So I really encourage people to do science, and if at some point they decide to become prime minister or president or parliament members, they should do it, because we need these people there to rebalance a bit the society, really. And please do it. And please, 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 if you are a woman, I mean, don't feel science is not for you. This is all wrong. I mean, science is for everybody. We need all the bright men, and we need you. And we're missing women right now because we're missing certainly gifted women for science that for some social and family pressure, they don't go into science, which is an absolute disaster. I think they should really join it and try. Diversity in science is essential to the science. When you look back in the science is about traveling, freedom of travel, freedom of expressions, and getting the best people in the world. I mean, there is a limited number of people gifted. They're all around the world, and we need to have them. If diversity is not represented into science, it means we're losing capability, we're losing people, we're losing brain. Well, now we have so many planets that the question of life is obvious. That's the next step. I'm absolutely convinced there must be life somewhere else, because I can't believe life is unique in the universe. There's too many stars, too many planets. That's pretty clear. Now, what is still not very well understood is what is the origin of life and what do you need as ingredients. Life is chemistry. And in a way, it's kind of a chemistry that is turning bad, because the chemistry that leads to something that is evolving and then by itself evolving to something more complicated. Now, the question is, what do you need? And we definitely can look at this in the lab here on Earth, and we can look at this on Mars, on Venus, and Enceladus, and there's a couple of other satellites in the solar system when you can look at that. And then you can try to look on other planets. The question, what exactly do you look at, is not very clear, but it is believed that at some point the geophysics of a planet should tell you something about whether there is life or not. It's a long way, it's a long path, because we don't even connect exactly the origin of life on the solar system. Now, this is something I've started spending quite a lot of time. I mean, I started this project a couple of years ago because that was my main focus when I moved to Cambridge, trying to establish something a new path here. And there has been progress. And the interesting part of this progress, the progress doesn't come from only astrophysics. It comes by combining what the astrophysicists are doing with what other people that are not really dealing very much with stars, because they're dealing with molecules in labs. It's called molecular biology. And there has been a lot of progress on the origin of life from the biology perspective, on the molecular biology perspective, the ingredients, the unit, what is the simplest unit, and how do you build them? And what is the condition for that? And then the condition is something that the astronomers can provide. I'm trying to get an idea, what is the atmosphere about? What is the kind of planet we're talking about? Do we have a plate tectonics? Do we have magnetic field? All this does it. What is the role of all this to initiate the chemistry, to have the chemistry right? And that's a new field, really, I'm talking about, which is at the boundary between different fields that connect different disciplines together. So this is my next big goal. I'm not claiming I will find the answer to that because it's a big questions, but I will definitely work on this. I am working on that already. The most obvious element that we're missing to the gradient right now is to find another Earth like us. We have failed right now because we have not been able to deploy the right equipment to do that. We know how to do it, we just need to implement it. So I have built up an international program of that called Terra Hunting. A lot of universities in the world with now having a whole equipment being built, and we will dedicate a quest for that kind of object with a telescopes doing only that, and there may be other in the future. And then we have to build up the equipment to analyze the atmosphere of these planets, and there will be a next generation of space equipment, and people are talking right now about this. So this is really my main activity where I'm moving right now, and I'm trying to accrete people, young people, on this. And hopefully, I mean, this Nobel Prize will be helpful for that, to stimulate this these new developments. I mean, people are convinced that this is what is coming next, but it's difficult to implement it because here, since we're building a new science, it doesn't really fit in the usual box. When you have a usual activity, it's easy, but when you do something really new, like life questions, so there must be life somewhere. We are going to make progress on the origin of life on Earth, and the possibility to find life that could be like the life we have on Earth or other kind of life, other kind of chemistry, certainly within the next 50 to 100 years.